Okay, people who are joining this live stream, we are talking about incremental language development for Wolfram Language as we head into the version 12.1 release. Some of what we're talking about is for that, and some is for after that. Okay, monitors as a headdress. Okay, let me explain what I'm. Is it obvious what I'm talking about, or is that?
No, that's why we wanted to ask you about
it. Okay, so with monitor, I can say things like monitor, table, pause 0.01 or something. I can do something like this, right?
Yep.
Where I can see that. But if I'm doing a map, I don't have any way to monitor it. If I say map this over, range of 1,000, there's no monitoring for that. So what I'm wondering is whether there's a headdress approach to that, where we can say monitored. Well, I wonder what there is. I mean, the thing that has worked really well is echo. Echo is really useful.
Mm-hmm.
And it would be really wonderful if we could have a way to, a monitor, in a sense, one of the things that's bad, and I don't know whether monitor has a curried form. Does monitor have a curried form? It does not. It's interesting, because one of the things I think would be useful there is to be able to say monitor of I at table, blah, 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 blah. Just like you can say echo at table. See what I'm saying?
Yep. But with a case like map, what would we write as a result of monitoring?
Well, I have a thing called parallel map monitored, which is either in the function repository or about to be in the function repository. It's very useful. And I think there's a number of things in the function repository that are monitored versions of map. I agree that it is not obvious how, it would require internal code work to be able to show the monitoring of the map.
But we could show the index of the element we are at the moment, or the element itself.
I think we want to show the index. I think the best thing would be the index. I think in a perfect world, we would have choice of what to show, but I think showing the index is already very useful. Or why not apply a function to the, why not have a map index style, #1, #2 thing, and the default would just be #2.
Right. We could follow echo function, which allows you to choose what to print.
Sure. Yes, exactly. But echo function, the problem with echo with respect to this is echo has the goods right there. It has the main payload right there. And you can basically just say, and it then is just having a side effect. The difficulty here is that I don't know how we get into the innards. What we would have to do for monitored of that is we would have to decorate F with the monitoring code, which is not the most impossible thing in the world to do.
Right. In a sense, it's like changing map to map indexed and changing F to echo the index.
Right. So in other words, it would do a transformation that monitored a map would turn into map indexed of something or another.
Right.
And yeah, go ahead.
Yes, the other thing I was thinking about is that we need an echo that can replace the previous echo so that we don't get a million echoes printed.
Oh, yeah. Well, it needs to be a temporary cell, just like monitor is.
Yes.
Monitor creates a temporary cell and then does its business. But the point is that what we would have to do with monitored is, well, honestly, the better thing to do would be if we were able to say monitor at, and then the whole map thing. We were able to just say that. In other words, have a one argument form of monitor that just monitors with respect to whatever it can monitor with respect to, so that you can insert it just like you insert echo.
Right.
The thing about echo that really I like very much is that, I use it all the time. And, you know, I just put it in, print stuff out. I use echo function occasionally. I realize that I need to look up how to put labels with echo. I assume I can just put a label
Yeah,
with one
it's the
argument.
second argument.
I see, but that means that I have to go and actually write echo, you know, that I have to do this echo hash label, right? Which is,
well, what I typically do is just writing the echo around the object I want to print and adding the label. If you have code with an X, you just wrap that thing with echo comma label.
no, I understand. That's what I do. But what I usually do is I put echo @ sign. I just insert echo @ sign in my code.
I see.
Which I find, you know, I find that really useful. And it would be great if I could just put monitor in my code and have it monitor, you know, do something reasonable. I mean, the difficulty is echo, it's very well defined what it does. It's taking the result, right? Monitor, it will be less well defined. It has to reach inside the system to be able to, you know, figure out what to do. I mean, and we'd have to support it function by function, so to speak. I mean, each function would have to get some kind of rewrite that would have, monitor would have to rewrite the function to something, and unfortunately it might lead to different bugs. We have various comments on our live stream. Ethan says it'd be nice to have monitor work with parallel things. Yeah, I've noticed that issue recently. I don't really know why it doesn't work. I mean, you know, the thing that I've been using, which I've at least privately put in the function repository, is, let's pull it up. I think it's supposed to go in the main function repository, but I think it has a conflict with another thing that's there. Let me see if I can pull this up. Is this guy? Let's see. Oh, that's really pathetically badly documented. But oh, it's really pathetic here. But if I do yeah, I do have it set up here. Parallel map monitored, let's say F range of 10,000 or something. It might happen rather quickly here. You'll see, oh, drat. Let's see what I can do here. Let's do a range, let's do a pause. Point 1 range of 1,000 here or something. Okay, now watch what it does. Okay, starting parallel map. See that? So it's giving me the fraction complete. It's giving me the fraction of things, and then it's giving me an ETA that it's computed.
Nice.
It's kind of nice. Right? I mean, I didn't write this, but Max wrote it. And it's, I think the only reason it isn't in the function repository right now is some conflict with another monitor thing in the function repository, which might be worth looking at as well. Let me just see what's there. Let's see, I'll be happy when the new search system for the function repository exists. Monitor download. I thought there was a monitor, something else, a parallel monitor. Okay, we got various comments here on the live stream. So the first thing is making monitor work with parallel stuff. So I don't know how parallel map monitor works actually, and I don't know why monitor doesn't work with parallel things. And I mean, I guess there's a question of monitor parallel table. Let's see what happens if I say monitor parallel table. And that is pathetic. Right. Yeah, that's pathetic. That is a bug of some kind. I mean, I don't know why that fails, but we should, you know, ask Roman, I guess, about that. Okay, let's take a look at some of these other comments here. Wrapper around iteratable things that provides a progress bar. Yeah, well, that's what we're talking about here, basically. It's just not easy to understand what is iterative. What counts as an iterator. I mean, we already have monitor for things with named iterators. Okay, we have a bunch of interesting suggestions here on the live stream. Let me go through them here. Carl says, complains that NetTrain has such a nice UX and map does not. Yeah, well, fair enough. I mean, NetTrain, of course, has a minimum operation that's much more complicated than map. So the fact that there's overhead associated with building a giant UI is irrelevant compared to the effort it has to spend doing the training. Whereas if every map had to build a giant UI, it would be bad. Okay, so dynamic map. Okay, nice. Okay, so that makes an interface almost worthy of, hold on. By the way, this is a really minor thing, but what is this doing? Why is that saying information panel? The font for this click here to update is really not consistent with the other stuff here. Devin, maybe that's for you to try to okay, click here to update. Let's see if it updated. And why didn't it tell me it updated if it did update? Now it's saying the most recent version is already downloaded. So that was bad. The click here to update should just either disappear or should do something when the update has occurred, not just sit there telling me to update again. Make sense?
Yeah.
Okay, I still think this isn't right. Where's the information panel? It's not generating, it's not displaying correctly.
Right. This seems to be expecting that function to work.
The information panel function.
The information panel, yeah.
I don't even know. I've never heard of information panel. Well, anyway, so perhaps that could be separately investigated. I think Itai is the expert on information panel.
Yeah, Nick should know as well.
Okay. Ali is complaining that we don't have a numerical gradient or Laplacian function. I agree, that is a bit surprising. We actually had an ND very, very long ago. That's a separate thing. Let's recycle that onto the back of this list because we're talking about different things right now. Okay. Wow. Okay. There is a Laplacian by calling ND solve mesh. Okay. Well, that's a separate issue. It's a separate issue. But is that for Devin? Who can bring that up?
Yeah, I can relay anything.
Okay. That is numerical Laplacian goes to Roger. It would not be the first time that we have functions where we've solved the hard problem but haven't exposed the easy problem. Okay. That's a nice progress report function that's doing what I would like. Okay, package for science on GitHub by Mathematica for Science. I do not know this. I mean, I've heard of this and I have not looked at it. So perhaps somebody else can look at it here. what is, well, TQDM is apparently a Python package, which maybe somebody could look at. Sander is suggesting that this dynamic mapping thing could be an option for parallel map. It'd be nice if there was a more general wrapper for doing this, and a way of adding and subtracting monitoring that was as easy as the adding and subtracting echo at. SWSH is suggesting things about table with a monitored range. I don't know why the monitored would be put there. I mean, I don't know why that would go there. I don't see why that makes sense. I don't think it's going to help it terribly much. I think it needs to see centrally. Well, I don't think the evaluation, I think by the time it's evaluated, yeah, I don't really see consuming those things. It's easier to handle the monitoring centrally than to handle it when it consumes every element, I think. Dynamic map is what people want here. Okay, Ethan is commenting it doesn't work in 12.1, which is I think what we're observing here. Yeah, well, right. So the suggestion from Carl is have map and things show this after some amount of time. I think the issue here is I see SWSH is suggesting that this thing with putting the monitor around the range would do something about creating an iterator. Not sure how that would work. Not sure how that will work. I don't think that's the way. The problem is that a lot of times we don't have an explicit iterator, like in the map case. By the way, somebody has a very seashore-like background sound there. Oh, now the seashore went away. Okay, so let's return to this for a second. So if we could do it, the possibility of something where we say monitor of map, blah, 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 people think would be good. Now, the only thing that's weird here is this is a one-level monitor in the sense that what it will be doing is it will be saying, take that function that I see here immediately before me and monitor it. So, for example, if we had something like a list of maps, we would not expect that to work. That is, that would merely be monitoring the list where it has little to say. Am I making sense? Which is why I had suggested a headdress type thing. What would be the case if we were to say monitored, if there was is there any one of these that would, let's see, what would that do? That would do the right thing, wouldn't it? Monitored a map. So if I do F star G of X, right? What does that actually compute? What does that do? That is equivalent to this. No, it's not. That's that. What do I need to do here? If it is what would that do? That does that. Oh, I see. This is kind of trivial. So obviously what it actually is F of G of X. But that requires those parentheses, and then it would do that. My gosh. In Python, it looks like pool processes. I don't even understand that piece of code. But this is for parallel computation, which is a little different. I don't. Yeah. Okay. Oh, well, that helps. Okay, I think someone else needs to try to understand this. But okay, back to the original question. So one question is, implementationally, how would we even imagine that it would work with things like map? Would they rewrite the map and then go and evaluate? Would we modify the internal code of map? What would happen? Thoughts?
To me, the simplest thing is to change the function itself.
To just rewrite it, as in rewrite it on the fly.
Right.
Like the monitor of map would not evaluate, and that this would then turn it. So let's imagine that we've got this, and that then this turns into I mean, let's imagine, just for the sake of argument, that that actually turns into, you know, this dynamic map of f of whatever. It's a little scary, and it might make code do different things.
Indeed, but it's the simplest solution.
Right. But, you know, that's why a headdress would be semantically clean. Because one could imagine, you know, one can imagine a family of monitored functions, as in they know what to do with what they've been given. Because, I mean, for example, what's a good example? Let's say, let me give you another example. Okay, monitored array. What would you like it to do? Not completely silly operation. You know, you've got a giant array. But, for example, yeah, I mean,
I think this will be reporting the position in the array at which it is working at the moment.
yeah, I agree. But I mean, so the way that would have to work is each one of these monitored whatever things would need custom code that goes and recreates array, essentially throw monitoring date, throw monitor info of the function of hash like this. Okay, here's another question. This metaphor here of throw monitoring info, we don't really have that metaphor. So in other words, if we had something that said monitor, yeah, I mean, the difficulty is this thing needs to know how much there is to do, right? So it can't be purely local to this.
Right. This needs a whole infrastructure. I think there was a project at some point on trying to homogenize all the progress
There
monitors.
is, yes.
Yeah,
maybe Devin can say something to that. Who is PMing that now?
That's me, and we actually have a meeting next Friday about it, which includes you, to go over Julio's framework for standardizing progress monitoring, which he's currently working on.
Great. So if we do one of these things, it should plug into that framework.
Yes.
By the way, we should live stream that meeting. I think other people might find it interesting.
Sure, I can suggest it.
All right, I think we have to move off this topic, but clearly there's a bunch to do here, and let's bring this up again in that meeting about the progress monitoring framework.
Okay.
Okay.
Yeah, so this was another question you formulated recently about the relation between mean around and other around objects. And so here I tried to explain what's going on, and at the end there is, sorry, an extension suggested. So yeah, can you go up a bit to the previous formulas?
Which one? Okay, so the issue that I had is if we take mean, so if we do, let's say, you know, random real.
You mean list 20,2?
I mean list. Thinking of it like a table. Okay, and if I say mean of this, it goes in and does the column, you know, whatever you want to call them. It does it just adds up every all of these, right? And then now, but now, if I were to put in around numbers here, it doesn't. No, wait a minute. I was trying to do mean around. That's
exactly.
right.
If you do mean around, you should get the same vector plus the covariance information. Right, because what this is saying is that mean is correlated. It's a vector with correlation information, which is in the correlation, sorry, not correlation, the covariance matrix in the second argument.
Why didn't I get that when I tried this a few days ago? Is this new?
No. This has been always this way.
Huh. Did I get something that had, well, okay. What about if those are random integers?
Same thing.
Well, okay.
Now, the thing that the thing I thought you were worried about is the fact that the covariance matrix is divided by the number of objects, because the covariance is not about the distribution itself, but about the mean of the distribution.
No, I was confused by something vastly simpler than that, which was that when I did this, somehow it didn't give the result. That it didn't give this result. It seemed like mean around wasn't working on lists, but it seems to be working just fine.
Yes. It's able to realize I'm working on lists, so I have to use vector around. I mean, if it took a list of integers, it would return around, scalar, normal around.
So this is quite beautiful. And by the way, you should show the workflow in the documentation from the mean of those things, mean around of those things to the around, which then ignores the covariance.
Exactly. It takes the diagonal elements.
That's beautiful. Okay, so what are you proposing over here?
Right. So the other thing here is the difference between around of a list of numbers and mean around of that same list of numbers, which already works for around and partially for vector around.
Wait a minute. So if I say 1, 2, 3 here, what is that doing?
Yes. So what this is doing is, so if you take around of a distribution, what we agreed is that would take the mean and the normal distribution. Exactly.
Okay.
Now, most of the statistics functions are able to handle distributions and lists of numbers that represent a realization of that distribution. So around does the same thing. So around is going to say, oh, if
I didn't know this worked. This is cool that this works.
Right, because that's fitting a Gaussian and then extracting the values.
Okay, so is mean around going to give the same result? No, it doesn't give the same result. Fascinating.
Exactly. So that's the difference I wanted to discuss. So what mean around means is that it's computing the mean, and then it's giving you the uncertainty of the mean itself, which is the uncertainty of the original divided by the square root of the number of objects. So if you keep adding more and more elements distributed in the same way, the around will stay, but the mean around will get more and more precise, because as you have more elements, the mean gets more precise.
Okay, so you're saying if I do this,
right,
and then I say 100 of those, okay, and let's say I do 1,000 of those.
Exactly. So exactly.
Okay, it's much smaller. Okay, whereas you're saying if I just do the around of that, oops.
Right. That's getting more and more precisely. But it's always 2 no matter how many numbers you have.
I see. That makes perfect sense. This looks just exactly right.
Right. So vector around is able to do partially the same thing, but not the last thing you have there. Vector around cannot do it.
Which last thing?
The very last, that one. So around of a multinormal distribution, vector around of a multinormal distribution should work.
Okay, I think that's a corner case. I think it's cool to make it work, but I think I had no idea that this worked.
Yeah, I mean, it's to me, it's the natural extension of having around working on distributions. Because if you go to the page of, I don't know, standard deviation, It works both
Sure.
on distributions and lists. It's the third one, but of course, interpreted as a list.
No, it's not listed in here. This is x1, x2, x3, x4. Right? This is a distribution.
Right.
I don't think it's listed here.
Yeah.
Oops. This threads over the list, but you don't give the one argument form of the x sub i's.
Right. Right. Yes. Yes. I thought it was kind of implicitly included in the distribution case, but yeah.
I certainly didn't figure that out.
Okay. So then we should add.
I think you should flip around the round of S, then a round of dist, and then the last one is a round of x1, x2, x3.
Right.
It's great. I wish we had support for a round in more places.
Yeah, that will come gradually.
Is Gosha working on that? Is that, I mean, getting it in the fitting functions and things is the next important thing.
Right. I think not yet. She's busy with time series and special statistics.
Okay.
Mm-hmm.
3 new ways of wrapping.
Okay, yeah, so this is 3 parallel discussions we are having, and I think they are very related, and we need to understand what the relation is. So one is the discussion on paired.
Mm-hmm.
The other one is something we started last week with what we call list applied, which I think it could be very useful for our transformation functions, which take lists rather than multi-arguments.
Yes. So so the idea, it's just like reverse applied, where you take this and it gives this. So you're saying list applied.
Yeah, there's a bit of code on the left.
Okay, I see it. And by the way, we've now also got operator applied.
Right.
So here, I agree that this is quite interesting and quite useful to have. Let me just think about this for a second. So the whole point is this list applied on its own like that is equivalent to f of this, isn't it?
Yes.
But arguably, the list applied form is more readable.
Exactly.
So here, I see. So you could then give, it's like you don't have to put the list around the elements. I mean, unfortunately, there's the sort of unlist applied version too. Well, that's apply, isn't it?
Yes, exactly.
The kind of parent of all applied functions is apply itself, which does that. Right, so this is an inverse of apply. List applied is an inverse of apply, in a sense. It wraps with a list.
Right.
Okay. By the way, a couple of questions about around from our live stream. Carl is saying he expects around to be a normal distribution around the middle, but that's not strictly the case. Well, it is the case that you can just say around of the normal distribution, but there's a whole long story about the extent to which around isn't really a normal distribution. It's something with its own separate calculus because it can't follow the whole story of the distribution. But yes, you can do that. I'm sure if I put in here something like, a Weibull distribution or something, what is it going to do here? Is it going to use the mean and standard deviation of that distribution?
Yes.
Oh, wow, that's really spiffy. What is that doing?
Yeah, for some distributions, it realizes they are asymmetric, and then it does the asymmetric.
What are those asymmetric things? What are they computed as moments of the distribution somehow?
Yes, they are computed from the distribution itself.
But what does that mean? The previous thing was its variance, wasn't it? The plus minus in the normal distribution case was the variance of the normal distribution, wasn't it?
Yes, and this is also a variance. It's also.
How can it be a variance if it's asymmetric like that?
So I don't remember the exact formula right now. I can look it up. I was thinking for some time about what's the proper way of doing this. But it's computed. It's not something that is predefined for each distribution.
Right. Just a second. Okay. I'd be curious how that's actually computed. But anyway, okay. Attach coordinates. What is this? Oh my gosh. What is this doing?
Yes, sorry, I was looking at the formulas. Yes, so the idea here is that we get an array of data, which could be also potentially dates or positions,
These are really indices, aren't they? I mean, this is really like map indexed. This is really a prepend map indexed, yes.
By default, but then the second argument can rescale those indices. And then we could say, I don't know, if we have an elevation array, it corresponds to these lats and these lawns.
Right.
So it's basically just a rescale.
And in principle, we could have a third argument, which is something about how the things are packaged in here. I mean, this prepend packaging. So, I mean, this is a variant of map indexed somehow.
Mm-hmm. Yes. Well, we don't have a function to map. We always know what to do in that sense. But
well, we do, in fact, have a function to map, but it's being given as a sort of footnote third argument. Because, I mean, I can imagine cases where what you really want here is a rescaled, something arrow C. Various people are commenting on a round. By the way, is it in fact true that a round of the list of numbers is equivalent to a round of empirical distribution of those numbers?
Probably not, because in a round there is always this Gaussian assumption. And I can imagine empirical distribution will try to fit to other distributions.
Maybe we should, for the properties and relations of a round, we should figure out what's true. Sandra is saying that linear model fit should handle around numbers. Yes, indeed. Indeed. Okay, let's go back to this. All right, so let's review these. So paired is a special case. No, paired is not a special case. Paired is a little bit like the attached coordinates idea.
Exactly, yeah. To me, these are three ideas in which we have data and we wrap a list, potentially with other stuff around it. And so I have the impression that we are after something bigger.
Yeah. Well, so where does the data come from? In some cases, it's just you always wrap the list. In other cases, it is an indexed version of that, where the list you're wrapping contains You know, there's something, there's a greeting card inside the wrapping paper or something. You're putting something else in there inside the wrapping.
Right.
Actually, there isn't. No, this doesn't have additional wrapping in the same sense that list applied has additional wrapping. This is simply, this is packaging each element here, and I don't even know what level number it goes to and so on. That's a separate issue.
Mm-hmm. Well, it's realizing that this is a rectangular array up to level 2 and then going there. And then the example at the end has a third argument in which we could put multiple things. And in this case, it's just a rule, but it could be other things.
No, I understand, which would otherwise be prepend or something, which would otherwise be, normally that would be basically append to #2, assuming that's the index, #1, which is the element.
Exactly. Yep.
Or if we were going to be really spiffy, this would be reverse applied of append. Right? That's it.
Right. Mm-hmm.
As opposed to that.
Yep.
Okay. Okay. Brian is asking, will attached coordinates work with images, video, and audio? I don't understand how.
Right. They don't have a way of inserting the information in the image.
Yeah, I mean, what we have there is this
I think in image processing, they use the data range option, and that's a way of specifying the range that corresponds to the 2 axes of the image.
For what purpose? I mean, that's for the equivalent of map indexed and so on.
Right. For example, in image transformation, your function may be working on a space which is not directly the space of the pixels. So by specifying data range, you can map one space to the other.
Right, but that's not. But it's not annotating the object itself with the coordinates, with the indices.
Exactly. No, it's not. I don't think they have a way to do that in image processing.
Okay, but in our wait a minute. Wow. Mapping paired. Yeah, I agree. Mapping of paired.
Yeah, I think mapping paired is going to be the most frequent case, and it's very useful.
Right. Yeah, that's very useful. Now,
sorry, it's like attaching the coordinates to the range of mapped Fs.
yeah, I understand. Okay, what's the generalization of paired? The wrapping head, which
exactly.
is.
Yeah. So you suggested to have it in the first argument. Here, I would prefer to have it as the last argument to follow, for example, what inner does.
Yeah.
But then I was worried about the evaluation. This is the wrapping head subsection. So which of these 2 results would be the right result?
I think the first one is a much more useful result. But I'm not well.
I mean, if we use a holding function, why would we use it there?
Yeah, right.
Because it may be that head and x don't evaluate by themselves, but head of x does.
I'm not sure. That's a separate issue. But let's talk about the relationship between this construct Yeah, so what would happen if I say map indexed paired of f onto range of 10? Oh, I see, it was fed too much stuff. But it's not obvious to me that that's right, that it was fed too much stuff.
We could do something with it.
Yeah, that's what I'm thinking. I'm thinking this is very much like the attached coordinates business.
Right.
Because this yeah, a comment from our live stream from SWSH around could be treated like low level numbers with its own algebra like complex numbers. Absolutely, that's what Jose spent a large amount of time thinking about. Absolutely. It has its own elaborate axioms, basically.
And now that we were talking about a round, I looked at the code. What it's doing is that for a round of a distribution, computes the median and the mean of the distribution, and based on that decides whether it's a symmetric or asymmetric distribution. And if it is asymmetric, then it will do a quantile computation.
I see.
With the same numbers as the standard sigma for normal distributions. And that's why this is a definition that goes continuously to the symmetric definition.
That makes sense. Sounds good. Okay, look, let's look at this thing, and we have to break in a minute. And actually, for people on this live stream, we're about to start another live stream about public Packlet repository. I need to get a bit of chocolate in between, but which I think people might find of interest, and we'd be interested in people's feedback on. Let's see, but let's just address this for one more moment here. Yep. So, I mean, this is the question of what is the relationship between this paired function and, so normally with the single map here, this becomes that, right? Now, with the map indexed, we've got both. I'm confused here.
If the range of 10 was a range from 10 to 20, then the numbers wouldn't have to be the positions. And so,
no, that's right. But in the map indexed, that would do that. But then this would be
right. And that will be different.
Yep.
And both are useful.
Indeed. Right. So in your attached coordinates, you're basically using the, I mean, there's different emphasis here, because here there's an F being wrapped around each thing. Here, this is purely the F is identity, but you're packaging in the map indexed indices.
Right.
In this case, using the reverse applied append here.
Right. I see your point. So we have several functions which are particular cases of a single operation, which is like attached coordinates but mapping a function at the same time.
That's right. I don't understand the unified version of this, but and it's possible that there are two different defaults that are both useful. I mean, I think the paired function is clearly useful.
Yep.
And right, but it doesn't know. So paired could perfectly well take as a #2, so to speak. It's, yeah, I mean, if what it did, I'm still a little confused about this. All right, I think we need to go to the next meeting, but let's start the next one of this series with talking about this issue. I think we're making some progress here. Okay, I encourage. Are you coming to the Packlet repository meeting, Jose?
I'm not. I could, but it's not in my calendar.
Okay, then don't worry about it. Okay, let's wrap this up. All right, so we'll be at this other meeting in just a moment here. Thanks, guys.